Hello, everyone. Hopefully you're with me. You should be in It's Always Math Time, 10:15 to 11:05. And I'm Angela Russ Ayone. It takes me 50 minutes to introduce myself, so I'm going to skip that part and we're going to get started. Okay, except I can't get the slide to move on. Is it my slide? Oh, there we go. Okay, sorry. Handouts are on the California Department of Ed website. You can find everything there. Today's outcomes, where we're going to review early math. We're going to take a deep dive into number sense. We're going to understand how to support math growth, and we're going to create a small math activity. Slides are all left justified, so if you want to move any images to the right or my video to the right, that was fine. Images float in and out. I encourage you to look at the images because I read the text, I do the text, and then you look at the images. They give you ideas for activities and support what I'm saying. Listen for examples of open-ended inquiry. I'm going to give you that quite a bit through different slides as an example of what to say to invite children to dig deeper, to delve deeper, I should say. And when you break out, I'll need you to assign a spokesperson to share with the entire group. So every breakout we'll do two. I need you to assign a spokesperson. Why math? Well, it's the language of science. It's the foundation for engineering, and it's the power switch for technology. We just listened to a keynote talking about what children want to do with their lives. And math is a big part of many of the big paying careers where you can maybe afford to buy a home in Orange County. Children without adequate experiences in math start behind and lose ground every year after that. Intervention must start now in the pre-K, in kindergarten, at 3 years old. Without such interventions, children in special need of help are often relegated to a path of failure. People tend to make excuses when children have challenges learning math. Like, she will never be good at math because I wasn't good at it, which is baloney. Well, Johnny's much better at sports. Do we say that about singing? Do we say that about swimming? Do we say that about driving? Let's not underestimate what children can learn and when they can learn it. Our goal is to promote a positive attitudes and habits that revolve around math so children can see math as something logical and useful and worthwhile to make more relevant applications to real world challenges, to guide and invite children to delve deeper into math activities using meaningful questions and open inquiry, guiding them and inviting them to the other activities. The reason is because they don't know what they can do. They don't know what they have permission to do. You don't know what they're told no to at home, and you don't know what they're told no to in the classroom. So they need to know they have permission without limitations to explore, to experiment, to jump in, find creative ways to make learning fun. It is always time to integrate math with other activities and other activities with math. Learning comes from supporting that natural exploration every single day. Children understand and engage in math skills without learning and mastering symbols and vocabulary. They understand math skills without that. Why? Because they're naturally curious, because they emulate their older siblings and adults, and they develop their own understanding over time. They also build upon everything they already know and have been exposed to culturally, and in career. Their mother might be a travel agent or something like that. They're exposed to that all day, then they know that, right? So they're curious, they emulate, they develop their own understanding, and they build on concepts they know. Though many studies have proven there's no inherent math ability, like we're just born and now we're mathematicians, but some people do have a natural aptitude for mathematical thinking. My husband's one of those people. I call him a math magician. And anyone can improve their math skills through practice, study, and effective learning strategies. That comes from NAEYC. So even children, toddlers, let's say, who I'm sorry, I don't know why that's, oh my God. Even toddlers know the difference between two groups without counting. So a child who brings two bones, one for each dog that they see, and recognizes the quantity instantly by looking at these two dogs and knows to get the two bones, has developed number sense. Children practice math skills early and naturally every day through everyday activities. The sequence or routine for their day, we were just listening to the keynote talk about routines. They have one shoe on each foot, and those shoes come in pairs. Band-aids are dispensed according to the size of a boo-boo. They are shorter than their parents and can't reach the shelf. They want more candy, and they have a smaller bowl of popcorn. And knives and spoons and forks are slotted or sorted in the silverware tray. These are basic skills that they've learned as they're growing up just by observation, build upon these natural skills. What comes next, in other words? Early in life, the brain is more flexible and capable of reorganizing and adapting to change. This is not the time where we want them memorizing times tables, okay, and addition, okay? This is the time for fluid intelligence, not crystallized intelligence. Crystallized intelligence is saying, I counted to 20. I can only fit 20 buttons inside this jar. That's crystallized intelligence. Fluid intelligence is street smarts. How can I redesign this so I can fit more than 20 buttons in the jar? Okay, so we want the children to solve problems, to be innovators, not just come up with an answer. 20, I can get 20 in. How boring is that? Let's review early math. I'm using the California Preschool Transitional Kindergarten Learning Foundations, and I gave you a link to that on my handout. I use that a lot. I reference that a lot when I'm working. Also, the Dream book connection, all the free books on Dream, DREME, that is also on there. I heard the keynote reference that as well. And the California, there's one more that's at the end, but also the links are on your handout. So the volume 1 covers social emotional development, language literacy, English language development, and math. So it's free, it's a PDF. I gave you the link on the handout. What is early math? Organizing information, recognizing problems, solving problems. We help children learn from their experiences, adjust the way they think, restructure, and reach a higher level of math understanding. Early math is not a collection of unrelated facts and procedures with worksheets and times tables and things like that. That's not what early math is. These two children have pancakes they ordered from a restaurant. Their father said, well, she'll have the number 12. Well, she thought she was getting 12 pancakes, but the number is based on the selection and not the quantity. And these are things children learn over time. Early math development includes the ability to analyze change and understand that most things change over time, many changes are predictable, and most changes can be described either mathematically or scientifically. If you keep adding water, the cup will fill. Left out in the cold, the ice cream will melt. If you add coins, you have more coins. Add a number of months. After a number of months, seasons change. The sun is higher or lower at different times of the day. Over time, water will evaporate. Given time, plants will grow. When the bell dings, the cookies are ready. And when the puzzle is finished, a picture is made. Early math includes number sense. It refers to a child's ability to understand and relate to and work with numbers in a flexible and intuitive way. It is not just about counting. This is under number sense, by the way, for California Learning Foundations. It's important aspects of counting, number relations, and operations. And what I like about the Learning Foundations is it gives you a lot of examples, real life examples of how this works. But we're going to do a deep dive into number sense. So I need everyone to participate. Deep dive. Okay, so we're going to take the number 4. Oftentimes I will ask what your favorite number is from 1 to 5 or 1 to 3. We don't have that kind of time today. So we're going to use the number 4. So say the number 4 out loud. 4. Everyone say it out loud. That we can hear that numbers have a corresponding word. So we're going to take number sense and we're going to break it down into the finite pieces. Think about reasons why this number could be special to you. It's special to me because I have 4 people in my family, my husband and my 2 children. So 4 would be a special number for me. That means numbers can be meaningful and numbers can be shared. That's what children would learn there. Show the number 4 on your fingers. 4. Everybody hold up 4 fingers. Numbers can be recognized The concept of a number represents the idea of having that many. 4 fingers represents the number 4. Write the number 4 in the air. Write the number 4. Number 4. Numerals are symbols that represent numbers, and the numeral 4 equals the number 4. When we draw 4, we know it means 4. Numbers can be represented in different ways. We've held up 4 fingers. We can do it through numerals, pips on a die or dominoes, hash marks, word form, the word 4, using pictures and objects, and then through movement as well. We use these different representations of numbers to communicate our ideas. Count up to the number 4. 1, oops, I'm not supposed to use my finger. 1, 2, 3, 4. Cardinal numbers are used to count. We count in numerical order, and we count in a growing pattern just by saying 1, 2, 3, 4. Also, clap and count to 4. 1, 2, 3, 4. Count to 4 using your fingers one by one. 1, 2, 3, 4. We learn that numbers represent a quantity, that counting requires one-to-one correspondence. And when we count, the last number is the total. Hold your 4 fingers up, fold 1 finger down. How many do we have left? 1, 2, 3. Hold 4 fingers up, add 1 finger. How many do we have now? 1, 2, 3, 4, 5. Numbers are used to tell the difference and to calculate by adding and subtracting. Clapping and counting to 4. On top, 1, 2, 3, 4. To the right, 1, 2, 3, 4. Near our bodies, 1, 2, 3, 4. Counting can be used to discuss positions and directions and distance. What if we sing and move? If you're happy and you know it is the theme. Build a 2, build a 3, build a 4. Everybody, build a 2, build a 3, build a 4. Or we can spend a penny, spend a nickel, spend a dime. Spend a penny, spend a nickel, spend a dime. So numbers can be used in song to help us learn. 1, 2, buckle my shoe. 1, 2, buckle my shoe. 3, 4, shut the door. 5, 6, pick up sticks. 7, 8, lay them straight. 9, 10, do it again. So numbers can be sung and we can have fun with numbers. We have to introduce concepts of math that in a fun way. Now, what if we were learning number sense with our peers? We can't do that here because we're not moving around the room together. But if we had our peers with us, we could form small groups by finding others with a matching number. Maybe others with a 4, others with a 3, and others with a 2. So then we're learning that numbers can be used to compare, contrast, match sets, and sort, which is their algebraic function. Everyone in my group likes the same number, the number 4 or the number 3. Everyone in my group is holding up 4 fingers, and I found all the children that had 4 fingers. They're all in my group. Having formed a group, count the number of people in the group. Numbers are used to define how many are in a set. What if they line up and count each person from front to back? They learn that when counting, the location of what you are counting does not matter. If we jumble up and we reline up and we count again, we learn that it does not matter what order we are in, the quantity is going to be the same. Numbers can be used to identify. If you were the number 4, please wash your hands. Our ordinal numbers indicate the position or order of elements in a sequence. What did you do first? We stood up. What did you do second? We lined up. And what did you do third? We counted, right? So it's a sequence of events. What if one person steps out of the group? How many are left? We have, again, calculation. Numbers are used to tell the difference and calculate. Numbers help us reason and solve problems. Oh, we need to play a game, but we don't have enough people in our group. What if everyone took 2 steps back from the group? Then we can see that numbers are used to measure, and numbers can be used to combine and separate. What if they line up and count 1, 2, 1, 2, 1, 2? Then we understand that numbers help us recognize and make and extend patterns. What if they line up in order from tallest to shortest? Well, then we've got seriation in the measurement strand, the ability to range objects or items in a specific order based on size, length, height, or quantity. And it helps children recognize patterns, compare sizes, and order objects systemically. What if you look at another group next to you? Can you tell if their group has fewer people or more people or the same number of people? We can use numbers to compare quantities or units of measure. Can the children tell how many people are in other groups without counting? That would be subitizing. That means I can look at a group of 3 or 4 and I know, like that child that gives the bone to the dog, that there are 3 people without actually physically counting the people. All right, we can tell how many are in the set without counting. What if the children use their bodies to make any shape with 4 sides? Numbers can be used to design in the geometry strand. And then if the children can describe their shape to their peers, we have knowledge of shapes and their characteristics. Look at that. They're making it square because they use the number 4. So we're going to break into groups. And we're going to design a 10-count hand jive. Don't forget to assign a spokesperson. A few will unmute and share after 3 minutes. But a hand jive, I'll give you an example, would be, and you see the pictures on the table. Let's say I'm flapping 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or it can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It can be anything you want, but you're going to break into groups and you're going to design a 10 count hand jive, and we're counting obviously to the hand jive. Think about the children that you're dealing with, the age group that you're dealing with. You're only going to have 3 minutes, and we're only going to have a few people that are going to share when we come back. Naomi? Naomi? We're breaking out.
Yes, the rooms are open. People should be, I just opened them. Everyone should be going into them.
Okay. Yeah. I can't see anything but my screen, so.
No worries. Yeah, it looks like people are in the rooms now.
Okay.
Yep.
So they'll time out after what, 3 minutes?
Yes, I can close it out in 3 minutes.
Okay. I should have set my timer so I can see. I don't see a timer on here. Start. I can get an idea. I know I can go into the breakouts too.
Yes.
Can't remember how to do that.
If you click on the breakout button, I think it's in the more.
Okay, I want to see it.
And
But it says there's only 2 rooms. Is that right?
No, there's 38 rooms.
Okay, got it. It just has a 2 next to the breakouts.
Oh, those are unassigned for the 2 of us who are not in a breakout room.
Oh, I see. Just us. Okay, perfect. All right.
Marilyn, I see that your hand is up. Do you have a question that you would like to ask?
Maybe she clicked it by mistake.
Yeah. Okay.
Yeah, I need you to deal with those because I'm focused and I tend not to see things when I'm focused.
No worries.
I think I'm coming back. Okay, yeah, I'm coming back to this. Okay.
For those who were not able to join a breakout room, there should have been a pop-up for you that asks you to join, and you have to press join.
We're at probably 2 minutes now. I know I'm not giving them a lot of time, but
No worries.
sometimes the pressure is worth it. Thank you, Naomi.
Of course.
Really makes my stress level reduces my stress level.
I totally understand that. No, it's nice when someone else is watching for those other things.
Yeah, I'm not very technical. I keep things very simple. And on Zoom, I don't typically have anything,
Mhm.
crazy, because I've had things that didn't work before, and it's like, okay, that's it.
Got it.
Excuse me. Still have a residual cough from that cold, flu, or whatever.
So sorry to hear that.
Yeah, it's just residual.
Mhm. All right.
They coming back? Should be 3 minutes.
Yep. Closing rooms.
All right. So who would like to share?
I think they're still there. It's closing
Oh,
out, so it's coming in.
okay.
Okay, they should be back in now.
Okay. All right. So who would like to share with us? If you want to share, you need to unmute to share with us so we can see you. And I need at least 2 volunteers to come forward and show us your hand jive.
If you would like to share, you can raise your hand. There's a feature in your Zoom toolbox.
Oh, good. Okay, here we go.
All right, so.
All right, I'm not sure.
All right, I'm allowing Patricia Ramirez to talk.
Great. Patricia, can you unmute? Oh, there we go.
I don't see myself, but anyhow, there we go. That's fine. There's no picture on there, and we did the 1, 2, 3 taps on the head,
Ooh,
and then we did 3 claps, and then
okay.
3 slaps on the legs, and then just like a pow out, just like the ending, like both hands.
Did you say a bow out?
Like both hands up. We just raised both hands like the finale.
Oh, that's cute.
Yeah.
Okay, 3 taps on the head. 1, 2, 3. What was the next one? 3 claps?
3 claps.
1, 2, 3.
3 slaps on your lap.
Oh, pats on your lap. 1, 2, 3.
And then the grand finale with 2 hands up in the air.
2 hands in the air. Yay! Okay.
Exactly.
All right. Great. Thank you for sharing.
You're welcome.
Lane Carlson, can you unmute?
Okay, can you hear me?
Yes.
We kept ours very simple in patterns of 2.
Okay.
So we had just a series of 2 claps. We were bookended with 2 claps. So it starts with 2, and then it goes one over the other, and then fists, and then back to, and then it was, I don't know, I guess I call it jazz hands. And then back to the claps as bookended. So super simple.
Super simple. Clap 1, 2, one over the other, and fists.
Yeah, fists on top of each other, each direction.
Okay.
Then the jazz hands for 2.
And then
2 back to claps. Yeah.
Yeah. It's nice to end often with the same thing you started. And obviously you have to consider the age of the children and yourself. Are you even going to remember your own hand jive? It's a question, which typically I tend to forget. Who else would like to raise their hand? Anybody else?
I see Deborah.
Deborah?
Okay, we did sets of 2. I don't know what happened. I don't know why you can't see me, but okay.
I know.
You clap twice,
Mhm.
pat your knees or your legs twice,
Okay.
and then you wave your hands one above the other twice, and then switch which hand is above.
Okay.
I remember it from Greece, where they did the.
Oh,
Yeah.
yes, of course. Of course.
And then the thumbs back. 1, 2. Yeah.
Okay, 1, 2. Okay. All right. That's great. Thank you. Well, I'm sure you all had some wonderful, I can't get to all of you, but you get the idea of making basic counting, changing the hand jive, letting the children come up with their own It could be a clapping game or a hand jive. Obviously, if you've got a partner, a clapping game is very fun for children to come up with their own clapping game. It's very, very fun to do. So try that in the classroom. It's a simple, it can be a transitional thing, or it could be the first thing you do in the morning and the last thing you do when you go out. You can increase that to a 20 count hand jive. And if you're really daring and children can handle it, a 30 count hand jive. And I've actually seen students do the Macarena to up to 100. So things like that and that was in first grade classroom. So those are some really fun things to try. So hopefully you can feel like you can handle it. It's very simple. For those of you who are, not our parents and using the DRDP, we covered the cognition, including math and science in that exercise, the number sense exercise, for quantity, for math operations, for classification, for patterning, and for shapes. I already went through what we covered, one-to-one correspondence and forming things based on, forming groups based on numbers or attributes, things like that. 1, 2, buckle my shoe, repeated series of actions in order. So if you want to go into the DRDP, the cognition, then that would be where you would go. So everybody could go back on mute. That'd be great. Early math also involves 2D and 3D shapes, identifying, comparing, investigating, manipulating, building, describing, and discussing, solving puzzles, and using shapes to build structures. You can say this is a circle, but who cares unless you make it personal? We just throw out terms and things, but you can't just throw things out there. You need to make them personal. Can you find something else that's a circle? What object can you draw using a circle? What shape is your pancake? What else can you use to make circles? How can you sort these by shape? Those are under California Learning Foundations for Geometry, and it includes properties of objects, size, shape, position, and relation of objects in space. So something as simple as, a circle, there are a lot of activities you can do with it, but you want to make it personal. Okay, building and constructing experiences help children expand their understanding of geometric shapes and engineering. They understand mathematical structures and situations. I love this 3D coil paper art exhibit. Culture versus straight line, curve versus straight lines, comparing and contrasting. What's the difference between the square and a rectangle, or how shapes form and fit together? How did you know those pieces would fit? Length and number of sides. How can you turn this square into a rectangle? Size and number of angles. How can you make this shape out of clay, pipe cleaner, sand, foil, rocks? Symmetry. How can you make the other side look exactly the same? And then when we're talking about shapes, you want to discuss characteristics of each shape, trace it, count it, count the sides, count the number of shapes, manipulate the shape, construct with the shape, expose them to different types of shapes, atypical and non-standard. Because what happens when you just show them the top 2 triangles, they get home and their parents try to show them one of the other triangles and they say, no, that's not a triangle. So we need to show them different types, atypical, non-standard. We need to use terms like narrow, long, thick, short, tall, sideways. So they recognize that the triangle has 3 sides and 3 corners too, but it can look like any one of these shapes, because that child's going to go home and say, that's not a triangle, Mom. Math skills can be learned by building structures because they can be designed. You see that beautiful design. What if you drew your design before you built it? We want to encourage that. That improves your fine motor skills and whatnot. It can be planned. How do you know how much material you'll need? What can you do to organize your material? These are questions you can ask that are math related. They can be built and composed. What did you do first, next, or last? How can you use these tubes or wood discs to build something tall? That's all mathematical reasoning, solving problems in play, and everyday activities. Also, structures can be described mathematically. How can you tell how tall, wide, long it is? Which enclosure is big enough for the rhino? They can help you fix problems. What can you do to keep your tower from falling? How will you keep the screws in the wheels? They can be changed. What can you do to make your structure wider, higher, rounder, broken down and decomposed? How will you take your structure apart? How will we find these same parts or pieces next time? And I love the construction on the lower right side, using standard boxes from the kitchen and egg cartons. You don't need expensive toys. You don't need anything pricey. You just need just their imagination. Give them the tools and the materials. This again is mathematical reasoning, this section. Building and constructing with different materials keeps things new and interesting. Put some things away, bring out something different and new. Novel and new. That's what keeps children thinking about new, exciting ways to do things. And remember that stacking, transporting, and putting away all require mathematical thinking. Here you see us building with foam cut up foam swim noodles, with standard rocks and sticks found outside, with PVC pipe, with sponges, with clay, rocks, foil, and miscellaneous parts, loose parts, and then even packing foam. I get packing foam all the time. I constantly save it. And packing foam, you can use sticks or you can use popsicle sticks as well. So just find fun, creative ways to build and construct, and it doesn't have to be expensive. I think the noodles are 99 cents at the dollar store. Early math also includes measurement using standard and non-standard means, which means a ruler, a tape measure, but also sticks or chalk or any pieces that you have that you can find that are consistent size that you can use to repeat that measurement. Comparing and ordering by attribute, which would be length, size, or weight, using words like heavy and light and near and far and empty and full. It's about the words we use. Whole, half, pieces, and parts. What do you think is heavier, the rock or the feather? Or even talking about speed, moving fast, slow, or stopping and going, or walking, marching, running, racing. All of these are different speeds. Preschool age is when children gain many of the precursors to this kind of understanding about comparing, ordering, and measuring things. And that comes from the California Learning Foundations under measurement. So that's really fun stuff. Early math includes passage of time. Now, we're not talking about a child who can read the clock. Daily routines are time. Number of sleeps is time. Number of sunrises or sunsets, or the use of timers. I love the use of timers, or clocks if they can read them, but it's also digital clocks. Some young children can read digital clocks. Repeating and growing patterns, that means being able to identify them, describe them, replicate them, extend them, and create them. That means using daily routines as a repeating pattern, having objects in a repeating pattern, movement in a repeating pattern. If we were to count to 10 and count to 10 and count to 10, we have a repeating pattern on that hand jibe for movement. Counting is a pattern. 2, 4, 6, 8, 10, or 1, 2, 3, 4, 5. We're always adding 1. That's a growing pattern. Or just events. Recognizing patterns helps children understand sequences, relationships, and order in their lives. That's why patterns are so important. We need to talk about what we're doing and talk about what's happening. As parents, if you're getting in the car, we're going to open the door. We're going to unlock the door. We're going to open the door. We're going to sit in the seat. We're going to put our belt on, and I'm going to drive. Every time we get in the car, it is the same pattern. We're going to unlock the car, open the door, sit in the seat. I'm going to drive. Okay. So then going to a show, we buy tickets. We look for the section. We look for the row. We look for the seat. Every time we go to a theater, we go to the section, we go to the row, we go to the seat. We have our tickets in our hand. It's a pattern. We cannot get to the seat without finding the section. And that's why patterns are so important to understand, that we have a rhythm of life, let's call it. This is under algebra and functions, classifications and patterning in the Learning Foundations in Volume 1. So we're going to do a song. I need everybody to move with me. Can you all see me? If we can't, let me know, but you need to be able to see me. And we're going to shake. We're going to shake. We're going to mix. We're going to pound. And we're going to roll. We're making something. We're cooking. We're going to shake. We're going to mix. we're going to pound, and we're going to roll. Now I'm going to sing it because if I play it, it takes too long. Okay, so we are going to start. First, we start off with lots of time. It's kind of like if you've ever taken an aerobics class. She gives you lots of time to do the 2 steps, and then she reduces the time until we're moving pretty quickly. Okay, so ready? Everybody should be ready. We shake and we shake and we shake and shake and shake, and you should be shaking. We mix and we stir and we mix and stir and mix. We pound and we pound and we pound and pound and pound. We roll and we roll and we roll and roll and roll. We shake and we shake and we mix and stir and mix. We pound and we pound and we roll and roll and roll. We shake and we shake and we mix and stir and mix. We pound and we pound and we roll and roll and roll. Now we speed up a little bit. We shake and we mix and we pound and we roll. We shake and we mix and we pound and we roll. We shake and we mix and we pound and we roll. We shake and we mix and we pound and we roll. Very good. Okay, what do you think? Thumbs up? Okay, so that was a movement pattern, a sequence of events following a recipe, but it can be any sequence of events. We find the section and the row, and we sit in the seat. The section and the row, and we sit in the seat. You can sing a series of events. When you have a sequence of events and you sing about them and you give them a melody, children are more likely to retain the information because we remember how to sing. That's why we sing our ABCs. We recognize there's a change in rhythm. We sped up. We have fine or gross motor skills. You can move your whole body on this, but I chose to do just our fine motor skills. We can prepare a healthy meal. Hello. And then we can use dominant and non-dominant skills. Now, if you recognize this CD, it was actually in Head Start's I Am Moving, I Am Learning initiative, anti-obesity initiative. So some of you might already have it or even be familiar with it. Early math includes recognizing and making different lines and pathways. It's a pre-writing skill, understanding what straight lines, curved lines, wavy lines, and zigzag lines, identifying those, or horizontal, vertical, and diagonal. Those are some big words, but we say standing tree, fallen tree, or leaning tree. And encourage children to trace, cut, and make lines in sand, shaving cream, string, using string or tape or rope or chalk, and place beads or stickers on the lines that they have. You know, that's on the left side. You see, well, that's actually my son making the number 3 and holding up 3 fingers. So it's a pre-writing skill, understanding what the lines and pathways and which way their lines go, how they loop. When you make a 4, you're more using zigzag. When you make a 3, you're using wavy lines. Early math also includes positions in space. Young children develop their spatial sense through movement and interactions with objects in their environment. You want to use terms like behind and over and inside and between. And parachute play would be a great example of play that uses a spatial sense, or batting balloons with or beach balls with pool noodles, or rolling a ball along a pathway, or using blocks and large boxes to construct, or swinging up and down, which is also great for the vestibular system, walking on tiles and plates and logs or beams, or playing with a ball, or moving through an obstacle course. If you ask a child to describe the castle they built out of boxes, you are asking them to describe the spatial sense. Simon says, step on the green plates, or toss the ball scarf to your friend. Or let's act out the story using our bodies, because we need to know where our bodies are in space. If we crawl under a table and we try to stand up, that's spatial sense. We need to know that we can't stand up, right? Because we're under a table. Geometry, this is a geometry foundation, the properties of objects, and the relation of objects in space. And I love that chalk pop the bubbles obstacle course. That's one of my favorite images. In learning math, the crucial factor is not what the environment makes possible, but what children actually do in it, how they are invited to delve deeper, how to guide them to their next level of learning, and how to help make connections to the books that you read, and I gave you the dream link on the handout, to the game they played, to the puzzle they completed, to the shapes they sorted, or the colors they sorted, or to the scarf shapes they made, or to the pattern they saw on the zebra in the zoo, or to the poll you took. And you have to observe and engage them using what you know about them and their interests first. The existence of math toys and experiences in the classroom or home does not guarantee that a child will ingest or digest it. It just having it there isn't. You need to guide them to the next level. You know what the possibilities are, but they don't. So we need to create serve and return experiences. When a child serves by expressing a need or interest, an adult returns with an appropriate response. It reinforces pathways in the brain that are essential for learning and development. Children are invited to be active participants and become more willing to explore and engage in new experiences because you've given them permission. Children learn crucial social skills such as taking turns, empathy, and understanding social cues. And when children have consistent and responsive interactions between caregivers, it fosters a sense of security and trust. And they need that security and trust just like we do when we're doing an activity, right? We need to know that we're not going to be made fun of, that we're not going to be told that we're not right. We need to be given the freedom to make mistakes because there aren't any, right? So what's a serve? From a child, a serve might be pointing to something, depending on their age, getting frustrated or angry, or getting bored, or starting an argument, or shoving or fighting, fighting over objects, breaking things, asking a question, not engaging at all with the materials, or finishing a project. They're done, right? So how do you return? By understanding where a child is in their development, by being alert to their experiences, ideas, and creations. What if you number your cards to match the parking spaces? Having knowledge of their cognitive or linguistic, physical, and emotional development. Motor skills, know their motor skills, know whether something's real or make-believe, know whether they can sort items by color, know whether they know their basic shapes, or how well do they interact with their peers, or by expanding on the children's interest in observing their child-directed activities. Providing open-ended and more challenging materials, diversifying by creating novel and new experiences, by inviting further investigation or experimentation, by making language connections and naming things that they're seeing, doing, and feeling, and sequencing, introducing new and complex vocabulary, modeling the structure of language and the formation of proper sentences, and noticing notice the place a 0 on top of the 3. There's a pancake there. By using open-ended inquiry, there are no wrong answers, and you guide children to their next steps. By inviting children to go to the next level of learning, I can't say that enough. By not answering their questions or solving their problems for them. By offering support and positive feedback, not praise, but encouragement. And by allowing time for them to demonstrate their patience. Children need time to process language, think, examine, experiment. They need time to understand what you're saying, and even formulate a response. Patience and persistence leads to self-control and resilience. And by acknowledging beginnings and endings, establishing a routine that becomes familiar, and recognizing signals of frustration, anger, or being tired. Children need a variety of activities in all aspects and all domains. How can you discover which rock is heavier? How do you know how much muffin mix to put in the bowl? What if you put a smaller triangle inside of this one? How do you know which blocks are shaped like triangle or rectangles? What if you showed your horsey how many apples he could eat? And she's pointing to 9 apples. How can you sort the shells by shape? Or what if you lined the shells up before you counted them, right? So we need to ask the questions that take them on to that next level. Now, I don't know, do I have time? It's 11 o'clock, Naomi. Do I have time to break out, or should I just review? This child is serving. Remember, I was talking about serving.
You have about 5 minutes, sorry.
Okay, good. So this child is serving. What can we ask to take this child to the next level of mathematical learning? look at the image and think about what he's given. He's put pegs in a hole. That's all he's done. He sat down at the table, and he put pegs in the holes. So what can we ask this child to take him to the next level of mathematical learning? Take a minute. We're not going to break out. Try to think of a question or two that you can share, and you can put your hand up if you have one. So this would include, where can we go for number sense, counting, operations, and identifying numerals? Where can we go with geometric shapes? Where can we go with measurements or pattern or lines and pathways? All he did was stick his pegs in a hole, and he came up to me and said, "Look, teacher, look what I did." So take a minute and see if you can't come up with a question or two using the examples that I provided to take this boy. What else can he do with these pegs and this mat? Taking him to another level. He's done. He's served. He's finished. He has no idea what he can do next. This is his first day, let's say. And I don't have any hand raising on my bottom, Naomi, so I wouldn't be able to see if someone was hand raising. Maybe they're chatting.
Yeah, let me check. I see two people with it. Angela Alvarez.
See, I don't see that.
Angela, if you would like to speak, you can unmute yourself now.
Angela? Angela?
Hi, everyone. Can you hear me?
I can hear you. Do you have a question that you can ask to take this young man to the next level of learning?
I was thinking of the classification, small, medium, and large.
Yes.
Sorting and separating.
Yes.
And just pretty much like the one-to-one correspondence, and even take it to another level for his age of stacking, and then on top and seeing how many yellow pegs, how many red pegs, and so forth.
Yes, yes. Thank you. Does anyone else have a contribution? Thank you, Angela. Is it, Tamisha Hickenbottom, would you like to unmute? Tamisha? Tamisha?
Yes.
Yes. What's your contribution? What would you like to ask this child? I didn't want to say young man, by the way. It's just this child now. Tamisha?
Oh, I think I put my hand up for it. I don't think I put my hand up for it on accident.
That's okay. Then if someone else would like to, it says two other people have their hands raised.
We have Robin Williamson.
Robin, can you unmute for me? Robin? Not hearing well. Maybe someone else?
Can you hear me now?
Yes, I can hear you, Robin.
Okay. I had to go through all these screens that Zoom was giving me. I think that it would be a good idea to give him rubber bands and have him group the colors. That way he can make shapes.
Ooh, I like that. Okay, wonderful.
And
All
I
right.
think Norma would like to talk.
Norma, you want to unmute?
Oh, I couldn't figure out how to unmute.
That's okay.
Yeah, I had said the same thing, classification, and
Mhm.
you could also do patterning, or you could do measurement.
Yes, you can use them to measure. Yes. Let me share some of mine so that I don't run out of time. But he's serving, right? He's come up and all he did was stick the pegs in. But how did you do that? Would be one open-ended inquiry. How can you find out how many pegs you have? How many red pegs or other colors do you have? I know that the first contributor mentioned that. What if you took 5 pegs away? So that's adding and subtracting. What if you group the colors together? And you got classification, which you mentioned. How can you arrange the pegs by size or by height? Or how do you know which size or color you have the least or the most? Or what if you took one row away? Or what if you made lines, shapes, or numbers with the pegs? What if you made the shape smaller or larger? How can you use the pegs to make a pattern? How can you make the shadows longer? The shadows longer, right? How do the short pegs fit on top of or into each other? If you stack the pegs by color, which tower would be the tallest or the shortest? What if you built something with those pegs? How can you use the pegs to design an enclosure or a home for your animals? And what would the home look like if you added a room? How can you make one side look exactly like the other? How can you use the pegs to create a design? How can you use the pegs to measure something? Tell me about what you did, right? So look at all the options. This child served you. You get served every single day. It's just a matter of how you're being served and what is your return. And knowing the guidelines, knowing the foundations, reading those foundations, and it's not a lot of, it's not difficult. That gives you examples of how you can expand or mathematize their day beyond what they're already doing and building on what they already know. I hope this makes sense to you. And I'm happy to take a question if I have time. Naomi, I'm not sure.
I think we're at time now.
We're at time. I hope you all learned something today and you develop your serve and return experiences. Thank you so much for joining me.